This is the latest video in a series looking at chain efficiency and longevity. In the last video, I talked about the functions of the chain and also looked at its structure. At the end of that video, I said in the next video, that's this one, I'd be looking at the forces within the chain. However, I've rethought that, and before talking about the forces, I thought I ought to talk about friction and wear. Although this video is primarily about how to look after the chain, looking after the chain can help you look after the chain rings and the cassette too. First of all, I want to issue a bit of a health warning, and that's around tribology, the engineering science of lubrication, friction and wear, which can be very complicated. So for the purposes of this video,
I'm going to simplify things.
First, I'll be solely talking about solid components that interact with each other. And secondly, many of the rules that I give you will be very generic. That is, in specific cases, there will be exceptions. So what is friction? Well, in the case of a bicycle chain, it's the energy that the chain absorbs that doesn't do any useful work. It's a loss within the chain. That loss is usually expressed in terms of imperceptible warming of the chain. The wear within a chain is how that heat energy is created. So if we looked at the surface of the chain in microscopic detail, it would look a bit like this. And friction is mainly the wearing down of those peaks and troughs on the surface of the chain. There's a general correlation between friction and wear. The higher the friction, normally the higher the wear, and the lower the friction, the lower the wear. And that's why I've lumped the two together, because looking at things like friction can give an indication of how the chain will wear, and similarly doing things to reduce the wear can reduce the friction and therefore the losses. In order for friction and wear to develop, you need two things. First of all, you need a load or a force across the joint. In the case of a chain, for instance, that would be caused by the rider pushing down on the pedals. But secondly, you also need relative movement, and that, in the case of a chain, will be mostly due to the links rotating relative to each other. So for instance, the straight section between the chain wheel and the cassette won't develop any friction and wear because, although it's loaded, there isn't any relative movement between the links. However, as the chain rotates and moves towards the chain wheel, those links will then start to articulate because they follow the shape of the chain wheel. This rotation of the links is even more acute on the cassette because the cassette is a smaller diameter. And I'll be talking about the size of the sprockets and how that affects friction and wear in a future video. Similarly, if you took a chain up into space such that it didn't have any load on it, you could wiggle it around as much as you like and it wouldn't wear. So the two key factors are a force across the joints, in the case of a chain under tension, and relative movement, again, in the case of the chain, articulation of the links relative to each other.
Until now, I've ignored the issues of lubrication. In this section, I'll start to include that. We can get some insight into friction and wear by applying the Coulomb friction model. In this, the frictional force F is the product of the coefficient of friction and the normal force. This is a somewhat simplified model. For instance, real chain geometry is much more complicated than represented here. However, the model can give useful insights. The frictional forces are dependent on the coefficient of friction, which is largely dictated by the materials used, and in particular any lubrication applied. I will look into the lubrication of chains in depth in a future video because it is important. However, one shouldn't just focus on that because there's that other factor N, the normal force, and believe it or not, there are steps that you can take to reduce that normal force and therefore reduce the frictional forces too, and by implication the wear, and I'll cover those in a future video as well. Before we go on to that, we need to understand a bit more about the forces within the chain, and therefore I'll cover that in the next video.
I hope you found this video useful. If you did, then consider subscribing, and you can do that by clicking on the 5-minute velo roundel now. Please give it a thumbs up, and just to finish, here are the 2 other videos that I've produced in this series. So from me until the next video, it's goodbye.